Here is another result concerning multivariate expectations for random variables x1, x2 up to xn and constants a1, a2 up to an. So once again, no indication here if the random variables are discrete or continuous. This applies for both. And in addition, there's no assumption here about the random variables being independent or dependent. So this is a very general result. And it is the variance of the linear combination of the xi's is the sum of the ai squared's variance of xi. So these ai's are in a sense coming out front squared because variance is a quadratic operator. And to take care of the fact that these might be dependent, plus twice the double sum over I less than j of a sub I, a sub j, times the covariance of x sub I and x sub j. Now, there are two important special cases. In this first special case, we assume that these constants a1 up to an are all ones. When they are all ones, this becomes the variance of the sum is equal to the sum of the variances plus twice the double sum over I less than j of the covariance of xi and xj. One thing that is interesting to note about this particular special case is that the right-hand side is the sum of all of the elements in the variance-covariance matrix sigma. The reason for that is this term right here consists of the elements on the diagonal. And since the variance-covariance matrix is symmetric, this term right here is the sum over I less than j of the covariances. That's half of them. But because we are doubling and because the matrix is symmetric, this actually corresponds to the sum of all of the off-diagonal elements in the variance-covariance matrix sigma. Finally, if you start with the assumptions for this result, namely that all of these a's are equal to 1, and you throw on one more assumption, and that is everybody is mutually independent, what that does is it zeroes out all of the off-diagonal elements on the variance-covariance matrix, and you get the variance of the sum is the sum of the variances. But again, that's only in the case where you have mutually independent random variables.